3 of these things, but maybe 4, maybe 5, maybe 10, maybe more, by declaring one variable to store all of them instead of 3 or 4 or 5 or more individual variables. And the way to do this is by way of something generally known as an array. An array is another type of data that allows you to store multiple values of the same type back to back to back. That is to say, contiguously. So an array can let you create memory for 1 int, or 2, or 3, or even more than that, but describe them all using the same variable name, the same one name. So for instance, if for one program I only need 3 integers, but I don't want to sort of messily declare them as score1, score2, score3, I can actually do this instead. And this is today's first new piece of syntax, the square brackets that we're now seeing. This line of code here is similar to int score1 semicolon or int 1 equals 72. This line of code is declaring for me, so to speak, an array of size 3. And that array is going to store 3 integers. Why? Because the type of that array is an int here. The square brackets tell the computer how many ints you want, in this case 3. And the name is, of course, scores, which in English I've just deliberately pluralized now so that I can describe this array as storing multiple scores. So if I want to assign values to this variable called scores, I can do code like this. I can say scores bracket 0 equals 72. Scores bracket 1 equals 73, and scores bracket 2 equals 33. The only thing weird there is admittedly the square brackets, which are still new. But we're also, notice, 0 indexing things. To 0 index means to start counting at 0. And we've talked about that before. Our for loops have generally been 0 indexed. Arrays in C are 0 indexed. And you do not have choice over that. You can't just start counting at 1 in arrays just because you prefer to. You'd be sacrificing one of the elements. You have to start in arrays counting from 0. So out of necessarily solve a problem, but it definitely is going to once we have more than even 3 scores. In fact, let me go ahead and change this program a little bit. Let me go back to VS Code here, and let me go ahead and delete these 3 lines here, and let me replace it with a score variable that's ready to store 3 total integers. And then let me go ahead and initialize them as follows. Scores bracket 0 is 72 as before. Score 1 is going to be 73. Scores bracket 2 is going to be 33. Notice I do not need to say int before any, because that's been taken care of already for me on line 5, where I already specified that everything in this array is going to be an int. Here, this code needs to change because I no longer have 3 variables, score 1, 2, and 3. I have 1 variable, but that I can index. I'm going to here then do scores bracket 0 plus scores bracket 1 plus scores bracket 2, which is equivalent to what I did earlier, giving me back those 3 integers. But notice I'm using the same variable name every time. And again, I'm using this new square bracket notation to quote unquote into the array to get at the first int, the second int, and the third, and then to do it again down here. Now, this program's still not really solving all the problems we described, like I still can only store 3 scores, but we'll come back to something like that before long. But for now, we're just introducing a new syntax and a new feature whereby I can now store multiple values in the same. Well, let's enhance this a bit more. Instead of hard coding these scores as a problem, let's go ahead and use getInt to ask the user for a score. Let's then use getInt to ask the user for another score. Int to ask the user for a third score, storing them in those respective locations. And now, if I go ahead and save this program, recompile scores, I've messed up here, but now these errors should be getting a little familiar. What mistake? Let me give folks a moment. cs50.h. So that was not intentional mistakes all these years later. I need to include cs50.h. Now I'm going to go back to the bottom in the terminal window, make scores. OK, we're back to scores. Now the program's getting a little more interesting. So maybe this year was better, and I got 100 and a 99 and a 98, and there my average is 9.0000. So now it's a little more dynamic. So it's interesting, but it's still capping the number of scores at 3, admittedly. But now I've kind of introduced another sort of symptom of bad programming. There's this expression in programming too called code smell, where like something a little off, and there's something off here in that I could do better with this code here. Does anyone see an opportunity to improve the design of this code here if my goal still is just to get 3 scores from the user, but without it smelling kind of bad? Yeah. Yeah, exactly. Those lines of code are almost identical. And honestly, the only thing that's changing is the number, and it's just incrementing by 1. We have all blocks to do this better. So let me go ahead and improve this. Let me go ahead and delete that code. Let me go ahead now and have a for loop. So for int I gets 0, I less than 3, I plus plus. Then inside of this for loop, I can distill all 3 of those lines into something more generic, like scores, bracket, equals, get int, and now ask the user just once via get int for a score. So this is where arrays start to get pretty powerful. You don't have to hard code, that is literally type in all of these magic numbers like 0, 1, and 2. You can start to do it programmatically as you propose with a loop. So now I've kind of tightened things up. I'm now dynamically getting 3 different scores, but different locations. And so this program ultimately is going to work pretty much the same. Make scores, / scores, and 100, 99, 98, and we're back to the same answer. But it's a little better designed too. If I really want to nitpick, there's something that still smells a little bit here, that I have indeed this magic number 3 here that really kind of has to be the same as this number here. Otherwise, who knows what's going to go wrong? So what might be a solution per last week to kind of cleaning that code up further too? OK, so we could leave it up to the user's discretion. And so we could actually do something like this. Let me take this a few steps ahead. Let me say something like int n gets get int how many scores, question mark. And I could actually change this to an n and then this to an end, and indeed make the whole program dynamic. Ask the human how many tests have there been this semester. Then you can type in each of those scores because the loop is going to iterate that many times, and then you'll get the average of 1 test, 2 tests, 3. Oh, I lost another. Or many scores that were actually specified by the user. Yeah, question. How many bytes are used in an array? So the purpose of an array is not to space, it's to eliminate having variable names, because that just gets very messy quickly if you literally have score 1, score 2, score 3, ... score 99. That's literally like 99 variables potentially that you could actually collapse into one variable that had 99 locations, if you will, at different indices or indexes, as someone would say. The index for an array is whatever's in the square brackets. So it's a good question. So if I'm using ints for everything, and honestly, we don't really need ints for scores because I'm really likely to get a 2 billion on a test anytime soon. And so you could actually use different data types. And that list we had on the screen earlier is not all of them. There's actually a data type called short, which is literally shorter than an int. You could actually technically use char in some form, or even other data types as well. Generally speaking, in the year 2021, these tend to be overly optimized. Decisions, like everyone just uses ints, even though no one's going to get a test score that's 2 billion or more, because int is just kind of the go-to. Years ago, memory was expensive, and every one of our instincts would have been spot on because memory is so tight. But nowadays, we don't worry as much about it. Yeah. So what is the difference between dividing 2 ints and an error, as you might have encountered in a program like cache, versus dividing 2 ints and getting an error like I did a moment ago? The problem with the scenario I a moment ago was printf was involved. And I was telling printf to use a %f, but I was giving printf the result of dividing integer by another integer. So it was printf that was yelling at me. And I'm guessing in the scenario you're describing for something like cache, printf was not involved in that particular line of code. So that's the difference there. All right, we now have this ability to create an array, and an array can store multiple values. What then might we do that's more interesting than just storing in memory? Well, let's take this one step further. As opposed to just storing 73, 33, or 100, 99, 98 at these given locations,